So yes, dear friends, so in this lecture I am going to tell you how to derive derivation of shape function for 1D bar element in G.C.S. So what is the meaning of G.C.S? It is nothing but global coordinate system. Okay, so first let me write down the sketch for this derivation. So this is x. Why I am using? Because the derivation is being asked in global coordinate system. So that is I am using what? Global coordinate as the one of the coordinate here. So as we know that, so bar element is an example for one dimensional element. So for one dimensional element, example is bar element. So if this is node 1 and this is node 2, at node 1 displacement 1 will be u1 and at node 2 displacement will be u2. Suppose if I assume this distance, so from this reference axis is x1 and this distance if I assume as x2, then what is this distance? So one can easily say that if this is x2 and this is x1, then this distance will be x2 minus x1. So later I am going to consider this as length of element, right? So because this will be the length of the element, so that is the reason x2 minus x1 I am replacing here it by length of the element. Okay, so next, so coming for the explanation, consider a bar element, having two nodes 1 and 2 at each node 1 and 2 here and at each node there will be 1 degree of freedom. So what is meant by 1 degree of freedom? It means at every node there will be only one displacement is allowed. So that is the reason at each node there will be 1 degree of freedom. Let n1, let capital N I am using, let n1 and n2 be the shape functions at node 1 and 2. Similarly, u1 and u2 be the displacements at node 1 and 2. Okay, so in order to derive the shape function for 1D bar element, now I will be assuming some suitable displacement model in the form of displacement model in the form of what? So in the form of u is equal to a0 plus a1x. So I am going to call this as equation number 1, or otherwise you may consider u of x, or u of x can also be considered as alpha 1 plus alpha 2 of x. See guys, I can use any one of the equation. Here a0 and a1 represents constants, similarly alpha 1 and alpha 2 represents constants. Either I can consider this equation or I can consider this equation. So now I will be deriving the equation by considering this is my first equation. Okay, so now we have to write down the boundary condition. Okay, so how to write down the boundary condition? Look at here. At node 1 what will be x? At node 1 x will be x1 and u will be u1, right? At node 2 x will be x2 and u will be u2. Am I right? Okay, see here. Now considering boundary conditions at node 1 and 2. At node 1 what are the boundary conditions? X is equal to x1 and u will be u1. Similarly at node 2 x will be x2 and u will be u2. So I am going to call this as boundary condition A and this boundary condition B. So up next what I will be doing is I will be substituting boundary condition A and B in equation 1. Okay, so now I am going to substitute my boundary condition A and B in equation 1. Okay, so what is my equation 1? Equation 1 is, what is my equation 1? U of x is equal to alpha 1 plus alpha 2 x. Okay, so this is my first equation. So in this equation I am substituting boundary condition A. So what is my boundary condition A? At x will be x1 and u will be u1, right? So I am substituting these values in this equation. So u of x, in place of u I have to write u1. Okay, alpha 1 will be as it is, plus alpha 2, in place of x I have to substitute x1. So I am going to call this as equation number 2. Now I have to substitute boundary condition B in equation 1. Substituting boundary condition B in equation 1. Equation 1 is here only. This is the first equation. So what is my second boundary condition B? So boundary condition B is at x will be x2 and u will be u2. Okay, so in place of u I have to write u2. Okay, alpha 1 as it is, plus alpha 2, in place of x I have to write x2. Okay, fine. Okay, so what next? See, now I am going to call this as equation 3. So now equation 3 minus equation 2. Okay, now I have to do the subtraction here. Equation 3 minus equation 2. Okay, so what is my equation 3? My equation 3 is this one. u2 minus u1 is equal to, what is alpha 1 plus alpha 2 x2 minus of, equation 2 is here, alpha 1 plus alpha 2 x1. Okay, see. So next I have to simplify this equation. How to simplify this equation? So u2 minus u1 is as it is. So alpha 1 plus alpha 2 x2 minus alpha 1 minus alpha 2 x1. So plus alpha 1 minus alpha 1 is going to cancel. So in this equation alpha 2 x2 minus alpha 2 x1, u2 minus u1. Okay, so in this what I will be doing, I am going to take alpha 2 as common. So x2 minus x1, this will be, LHS will be as it is, u2 minus u1. So what is alpha 2 value? u2 minus u1 divided by x2 minus x1. So now I have got first constant value. So I am going to call this equation as 4. See, now I have got the first constant value. What is my constant values? Look at here, this is my first equation, alpha 1 and alpha 2. Our aim is to find out the constant of alpha 1 and alpha 2 values, then I will be substituting back in equation 1, right? So now I have got what? Alpha 2 value here. See, look at here. Now I have got alpha 2 value. Okay. So what next? So next is I have to, now I will be substituting this alpha 2 value in equation 2. I will be substituting this alpha 2 equation in equation 2. Substituting equation 4 in equation 2. Substituting equation 4 in equation 2. Okay. What is my equation 2? Equation 2 is u1 is equal to alpha 1 plus alpha 2 x1. So this is my equation 2. Am I right? See, now what I will be doing is, okay, so now here I am going to substitute what is my alpha 2 value. So what is my alpha 2 value? Just now I have found out. So alpha 2 is u2 minus u1 divided by x2 minus x1, right? So this value I am going to substitute here, alpha 1 plus u2 minus u1 divided by x2 minus x1 into x1. Okay, see here guys, now I want alpha 1. So alpha 1 is equal to, so this term I am going to bring towards my left side. So u1 minus of u2 minus u1 divided by x2 minus x1 into x1. Okay, see what next? So here I am going to take it as LCM, x2 minus x1. So if nothing is there, 1 is going to be here. So then x2 minus x1 into u1 minus u2 minus u1 into x1. Am I right? Okay. So what is up next? Up next I am going to simplify this equation. x2 minus x1. Okay. So here u1 x2 minus u1 x1 minus of x1 u2 plus x1 u1. This term into this term and this term into this term. So minus into minus will become plus. Okay. See here x1 u1 u1 x1 plus and minus is going to cancel. So alpha 1 will be u1 x2 minus x1 u2 divided by x2 minus x1. Okay. So in this what I am going to take it as common. So in this just a minute friends. So x2 u1 minus u1 x1, it is correct. So x1 u2 plus x1 u1, it is also right. So this I am going to cancel. Fine. u1 x2 minus x1 u2, right? Yes, so I am going to call this equation as phi. So what we will be doing? We will be substituting equation 4 alpha 2 value and alpha 1 value in equation 1 because just now we have found out constants of alpha 1 and alpha 2 value. So now I am substituting back these values in equation 1. Okay. So substituting equation 4 and 5 in equation 1. It means what? I am going to substituting alpha 1 and alpha 2 in equation 1. Okay, so what is my equation 1 is u of x is equal to alpha 1 plus alpha 2x. So what is alpha 2? Alpha 2 is u2 minus u1 divided by x2 minus x1. So what is alpha 1? So alpha 1 is, alpha 1 value is u1 x2 minus u2 x1 divided by x2 minus x1. Okay, so u of x will be as it is. What is alpha 1? u1 x2 minus u2 x1 divided by x2 minus x1 plus what is alpha 2? u2 minus u1 divided by x2 minus x1 into x. Okay, so since this term is common, I am going to take LCM as x2 minus x1. Okay, see what next? u1 x2 minus u2 x1. Here I am going to multiply this x to this term, so plus u2x minus u1x. Okay, so now what I will be doing is u1 I am going to take it separate and u2 I am going to take it separate. First, if I take u1, what will be getting common? u1 of x2 minus x here minus, I am going to take it as u2 as common. Okay, minus u2 I am taking it as common. Okay, otherwise I will be taking plus. If I take u2 as common, x minus x1, x minus x1 divided by x2 minus x1 divided by x2 minus x1. So I am going to call this equation as, what is my last equation? 5. So I am going to call this equation as 6. Okay, this I am going to call this as equation 6. Now equation 6 is in the form of u of x is equal to n1 u1 plus n2 u2. So I am going to call this as equation 7. Compare equation 6 and 7. Compare equation 6 and 7. So from equation 6 and 7, u1 will be as it is. What is n1? n1 is x2 minus x divided by x2 minus x1. And what is n2? Compare u2 will be as it is. n2 means x minus x1 divided by x2 minus x1. So thus now we have found out the shape function of, just a minute, now we have found out the shape function of what? Shape function of 1D bar element. Now I have to write down the variation of shape functions. Now I have to write down the variations of shape function. See friends, if you do not write the variation of shape functions in your exam, you are going to lose almost 1/3 of your derivation of marks, right? So to avoid that, as we already know that few properties of shape function, right? At this is node 1, this is node 2. At node 1, shape function n1 will be 1, and at the same time shape function at n1 will be node 2 will be 0. And what is this value? This is n1 is equal to what? n1 is equal to x2 minus x divided by x2 minus x1. This again I am going to write it as x2 minus x, and this is nothing but length of the element, as I explained in the beginning. See here, with the help of sketch I had explained here. So look at here. So x2 minus x1 means length of the element. Understood? Okay. So now I am going to write second shape function. So okay, this is node 1, this is node 2. N2 shape function will be 1 at node 2 and N2 shape function at node 1 will be 0. And what is the value of this? This is nothing but N2. N2 can be given as what? X minus x1 divided by x2 minus x1. Further it is written as x minus x1 divided by LE. Okay. So put together I can write like this. Okay. So this is node 1, this is node 2. So this is N1 is equal to 1, N2 is equal to 1. Here it will be field variable. Field variable means u of x is equal to N1 u1 plus N2 u2. Okay. This is u1 of x and it will be u2 of x. Yes, thank you guys. Thank you for watching. Thus completes this derivation. Thank you so much.